All right. Welcome. Today we are looking at uh, the source code for the GHC build system Hadrian. This is part of the theme day I've been calling theme theme Thursday. This is I should mention that this is part of a series of videos that I've been doing looking at the source code of various open source projects. I've got a schedule up. If you click on the live tab under YouTube, the time listed for when the stream is going to start is typically not accurate. It's a bit aspirational until I really work out what my schedule will be like from day to day. So I'm here on the GHC GitLab. There's also a GitHub mirror. And you can find, if you search, you can find repositories for just Hadrian from when they were developing the build system and it wasn't part of the GHC source tree. But those repositories are out of date and Hadrian has been merged into the GHC codebase. I have another video, which is on YouTube, where I do an initial look at the GHC codebase. So maybe check that out as well. And I should mention before I start that I am not a seasoned Haskell developer. I've never actually even written anything in Haskell. I only know a little bit, but I'm here to explore and see what's going on with the Hadrian build system. I guess before we begin and dive in, let's think a little bit about what we expect to see. So it's a build system. Its job is to build the GHC code base. And I saw before I started, I took a quick glance at a talk about why the move to Hadrian. And one of the things they mentioned was that they had been using GNU Make, and GNU Make is pretty old. I'm not sure how far back it goes, but a few decades old at this point. And there's a lot of, it's not easy to work with. It's not easy to make it do complicated things. It has a lot of global variables, and I think it does it like a kind of templating macro approach. And that sort of approach where you have like templates and macros, and you're instantiating them, especially if you do it all at once, then you have to rely on those values. That sort of approach is really brittle. And so a lot of people have moved away from like stock GNU Make toward more advanced build systems that do things like allow you to dynamically choose dependencies and whatnot. So since it's got to build GHC, we expected it to build some sort of graph, almost certainly a directed acyclic graph, which is going to be the graph of dependencies. If I want to build file foo and it depends on file bar, then the build system somehow should know that foo depends on bar, and it should build bar first. And we should also expect to see some sort of way of declaring that foo depends on bar, and then maybe file baz is optional if I have, let's say, a Sun Microsystem CPU versus an AMD or Intel type CPU. So those sorts of things should be declared somewhere. There should be some way of declaring those dependencies. And then there should be some code to analyze those dependencies and somehow configure and call a compiler. I think GHC is entirely self-hosted, so I imagine the compiler it's going to call is actually another version of GHC, but we'll see how it goes. And I don't know whether you're able to use Hadrian to build other Haskell code. So I guess I'll keep an eye out for that. So this is just the root repository. One thing I'm going to do is check the README. So it's the build system for Haskell compiler. It's built on Shake. I guess let's see what Shake is about. And there's a talk, or there's a paper here, and a Haskell Exchange 2016 talk. That might be a similar talk to the one I saw. I don't think that was on Haskell Exchange. I think the one I saw was like a Google Tech Talk or something like that. And put on the helmet and run the following commands from the root of the GHC tree. What helmet? Put on the helmet. Okay. So we're going to run boot and configure. This might be the just standard make configure, GNU configure script thingy. And then we're going to call Hadrian build -j. Not sure what J is. That might be optimizations. And then there's some different stuff on Windows where you need to enable tarballs auto download, and you need to call the bat file. J enables parallelism and is optional. Okay, so that's parallelism. We'll refer to the build script simply as build. And then there's some stuff about Windows. Haskell is written in Haskell. It depends on Shake, plus a few other things like quick check. If you've never built GHC before, you can start with a preparation guide. That makes it sound a bit daunting. And the fact that you need a helmet makes it also sound daunting. So I guess we'll see what we're in for. I'm not going to build it on this machine because if it builds successfully, that's not so interesting to watch. And if it doesn't build successfully, then it's not so interesting to watch me try to debug a build. So I'm not going to build it. I'm sure that it builds nicely, assuming you have all the dependencies. And if your first build is successful, we're going to run build to rebuild after some changes. So presumably this is at least somewhat incremental. So you can rebuild after changes, and hopefully the rebuild is not a build from scratch. And then build results are placed in _build by default. And they are build flavors. And the flavors are things like quickest, perf, and prof. Prof, I think, is profiling. Perf is probably something performance related, but I'm not sure how it differs from prof. And then we have devel 1 and 2. The quickest flavor adds the O optimization 0 flag to all GHC invocations and build libraries only in the vanilla way, which speeds up builds by 3 to 4x. So I guess it's saying that when you request compiler optimizations, those compiler optimizations take time, and that adds some slowdown. And then we have flavor transformers, which can slightly modify the build settings for a flavor. And we can do things like no profiled libs, don't build profiled libraries. Lint, build with core lint enabled, etc. Okay. So it's got kind of this API where you can choose options, bundles of options they call a flavor, and then you can modify your flavor. And then there's some command line flag stuff, which I'm not going to look at. Some stuff about expressions for specifying build settings. I guess let's take a quick look at that. And then we've got user settings. And it tells us how to build libraries and executables. And we can call build stage 1 : exe : GHC bin. Build the stage 1 GHC compiler and place the binary to the directory _build /stage 0 /bin.ghc. Okay. I guess this is presumably some sort of label in the build, whatever way they describe a build command or target. This is some name for it, I assume. And you can choose your compiler by, you set this GHC variable. And GHC is used to build Hadrian. And okay. We can get fast feedback. Running the GHCI script, which is GHCI is like a REPL, a command line interpreter thing that will interpret Haskell. Modules are only type checked, so it isn't possible to run any functions in the REPL. Okay. It'll load the main compiler into a GHCI session and I guess type check because you can't run any functions, right? And then there's some testing stuff. You can run linters, and you can call clean and do a full rebuild. And there's staged compilation. So it's a self-hosted compiler, and consequently, the build proceeds in several stages. It begins with a user-provided installation of GHC called stage 0 or a bootstrap. Then Hadrian uses the stage 0 compiler to build a stage 1 compiler, somewhat confusingly found in this direction, the stage 0 direction. Directory. And then stage 1 compiler is used to build new core libraries, and the stage 1 compiler is used to build a stage 2 compiler after it has the core libraries, linking against these new ones. And then optionally, the stage 2 compiler can be used to build a stage 3 compiler for further smoke test. I'm not sure what the various benefits are. Maybe stage 3 is when everything is fully built with the check.code instead of relying on anything at all from your original bootstrapping compiler. And here's a graph of the stages. Hadrian. I think maybe my, yeah, okay. I was obscuring the arrows with my CSS change. Okay, so Hadrian, all right, so GHC stage 0. What does an arrow mean? Does it mean build? Okay, so dotted arrow means X produces Y. Undotted arrow is X is linked against Y. And blue is GHC build dependencies provided by your system. So that's like the ambient environment outside of the code repository. The greens are produced during the GHC build, and the pinks are optionally produced during GHC build. Okay, so X is going to produce Hadrian. By X, I mean GHC stage 1 is going to produce, I guess by stages, these are supposed to be like the abstract stages. Is that right? Build dependencies. Okay. So your stage 0 compiler is going to produce Hadrian, and Hadrian is going to produce everything below, including stage 1, base stage 1, and integer star stage 1. All right. And GHC stage 0 also produces base stage 0 and integer star stage 0. And GHC stage 1 is going to produce, oh no, these are not productions, these are linked against these things. Okay, and then GHC stage 1 is linked against base stage 0. And then GHC stage 1 is going to produce GHC stage 0, which will link against the base stage 1. And optionally, we can produce stage 3, which is linked against base stage 2. All right, but base stage 1 is linked only against integer stage 1, which was produced by GHC stage 1. So already in stage 1, it looks like, stage 2 depends on stage 1. Okay. But stage 1 depends on this blue stuff. Okay. So it seems like in stage 2, we have no blue dependencies anymore. But we can optionally produce from stage 2 a base stage 2. And I'm not sure why we would do that, but if we do that, then we can move on to stage 3 and link stage 3 against stage 2. Okay. And here we get some sort of table. Hadrian path is user ... I guess that means it's on the system. All right, GHC runs on build target. All right, and produces code for build target. All right, I'm not sure. I don't know enough about building GHC to know why you would want all of like this extra step. Maybe it's something related to cross-compiling or something more advanced. But that's that. So here's something about expressions that I think it said are used to configure builds. Express CBA is a computation that produces a value of type action A. So somehow A is going to turn into an action of A and can read parameters of the current build target CB. So we're going to take CB and essentially wrap it into target. We're going to take A and wrap it into an action. And I guess it's going to be like an action A is like applied or is going to act on target CB. And so here's a definition in expression.hs. New type express CBA is going to be expression. We're going to get a new expression of reader T of target. Yeah, so we're going to do exactly what I said. We're going to wrap these things, and it's going to derive applicative functor and monad. So it's a new type wrapper, blah, blah, blah. Okay, so reader T adds a read-only environment target CB. In the case of Hadrian, the values of action A, it's equivalent of threading through target CB parameter to all of our functions. We only have to worry about it when we need it using ask, which takes a monad, which I guess, I'm not sure how to pronounce this, but this is like executed in the context of a monad, M. We're going to get this type reader T, R, MR, where R is target CB. Okay. I'm not sure what it's trying to explain, but somehow this is going to give you like a monadic environment for doing actions and whatnot. And I don't see anything about like how, or maybe here, way unit. So way unit has threaded, debug, profiling, logging, and dynamic. So I guess that's a different way that you could build the build. So debug build and profiling build makes sense. Threaded, I guess, is whether you're using multi-threaded. Logging is maybe if you want to log. I don't know why you would not want to log. And then dynamic could be any of several things, but I'm not sure what it does. We've got this package thing. This is maybe how you declare things like dependencies. So we've got a package type. The types are library and program. So in the Bazel world, this would be like lib and bin versions of a thing. We've got a name for the package and a file path, which has which is relative to the root of the build system, like at libraries cabal / cabal at. Okay. And then we've got some conversion stuff, like how do you get away, I guess, from a unit. And then we have builders. A builder is usually an external command invoked in a separate process via command. Here's some examples. Alex is a lexical analyzer generator that builds lexer.hs from lexer.x. And then we've got a bootstrap. The bootstrapping Haskell compiler, I guess, uses a builder. So the builders, examples of builders are Alex, auto-reconf, derived constants, cabal, the staged GHC. Action comes from, okay, so let's look at action. Action comes from Shake, the library underlying Hadrian. It performs IO using lift.io and keeps track of the dependencies for a rule. Okay. So I guess action is going to keep track of the dependencies, maybe among other things. And then we've got some predicates. A particularly useful predicate is question mark. Its real type and implementation can be found in here, but for the sake of illustrating how it works in most cases, imagine we have a rule defined like this, question mark, blah, blah, blah. If the predicate returns true, we return the expression we give it. Otherwise, we return empty. Okay. Say we want to compile all of the Haskell modules in compiler / with, I guess, no optimizations during stage 0. We can do that by going to user settings.hs and changing user args to user args package compiler question mark builder. Okay, I'm not sure if the thing that question mark replaced was something else. And then we've got this other question mark here. All right, so that's just a kind of quick glance at what the that stuff, expressions. And then what is Shake? Shake is a tool for writing build systems, an alternative to Make, scans, and etc. Shake has been used commercially. Okay, great. It compares itself to Ant. So it's like a build tool. It might be based on Make, which is why it rhymes with Shake. But okay, it's a Haskell library for building build tools, and I guess Hadrian builds on top of it. I'm going to re-enable dark CSS. Okay, so all right, here we are in the directory. We've got Bootstrap. Not sure if that's so interesting, but we'll look at the source directory, and that'll be where we will start. We've got context, expression, flavor, Hadrian, oracles, rules, settings, and way. And these are many of these things we just saw in the documentation: way, rules, flavor, expression, and context. And then for the Haskell files, we have base.hs, builder.hs, command line, context, expression, flavor. Okay, yeah, so this is a Haskell pattern I keep forgetting, but it seems very common to have like flavor HS is kind of like module metadata, and then there will be a flavor directory that kind of is the backing of whatever's in HS. This is a little bit analogous maybe to in C++, how you would have a header file, which is kind of the publicly visible API, and then you have the CC file, which is the rest of the stuff. And then we have settings, rules, stage, utilities. I guess given this structure, let's go ahead and look at the HS files first before we peek into the directories. I'm curious about packages and rules, and maybe target. Let's look at these first. Okay, so we're going to import some stuff. Seems reasonable. Shake, Hadrian utilities, a parser, IO, base command line, a bunch of stuff from rules, and user settings. Okay. So the main function is going to parse command lines, get the current directory, something about shake color. I'm not sure what color is. And we're going to configure shake and document kind of what we're doing to shake. And then rules. Is this a new function? This is still main, right? And then we've got this, I guess, rules. This is a type declaration, right? Rules is of type rules with empty parentheses. And rules is going to be this, we're going to use this do notation. And I guess these are functions, right? So we're going to call build rules, doc spec rules, documentation rules. These seem like types of rules rather than actions. I'm not sure what's going on here, but this is rule related stuff. And we're going to look at, I think, the rules directory later. And we have an IOREF. This IOREF is used to communicate the result of shake parsing command line options. Okay, great. Handle shake exception and escape foreground, which is just going to output the escape code in an M. Not sure why. And then we've got escape normal and some other escape. Okay, so we can escape and we can handle exceptions. And then this main thing just seems to configure a bunch of rules and configure shake. And how do we actually kick off the build? So handle shake exception, shake ops var applied to shake args options with options, command line, op deskers, shake ops targets do some option stuff. Let targets equal filter not null, remove KV's targets. So we're going to filter out some targets. We're going to set up the environment. And we're going to return just of shake ops if null targets, blah, 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 then rules, else want targets without actions rules. So does that do anything? It seems like from the names of these functions that this should just do some setup stuff. So we're returning shake ops something and some rules. So it seems like if this is main, then I would guess that it actually does some sort of, it does kick off the computation. But I'm not sure. I'm not sure how. I'll do a quick scan to see if got the shake output stuff. That's more option stuff. Okay. So this IOREF is used to communicate the result of shake parsing command line options, which happens in shake arg options with to the exception handler, which uses the verbosity and color information to decide how much of the error to display. Okay, so color is literal color, like the wavelength of light, and that's used for displaying errors and stuff. Okay, what is handle shake exception going to do? It's an IO A, and it's going to put string line to tell you that the build failed. catch with args exception, shake exception, do, shake ops, read IO ref, shake ops var. All right. So I'm not sure. I'm curious to see what actually kicks off the builds because looking at this, I don't see it. But again, I'm not a Haskell person, so I may be missing something obvious. All right, here we are in packages.hs. And these are all GHC packages we know about. Build rules will be generated for all of them. However, not all of these packages will be built. For example, package Win32 is built only on Windows. Okay, so there's some conditional compilation. So GHC packages is just a list of packages. We've got a Boolean that will ask us whether something is GHC package, and it's going to just check if something is an element of the variable GHC packages. Okay. Optimize by switching to sets of packages. Okay. Package definitions. So I don't know the syntax, but it looks like it's saying that all of these things are of type package. There's a big list, and then this double colon, which I think is used always for type declarations, and it's a type package. And then these, so array, okay, so it's declaring variables, I guess, for all of the packages that we know about. And the variable array is going to be equal to lib of the string array, and so on. For some of them, we'll set paths, like cabal is going to be in library/cabal. Okay. So this is kind of like we have a string, which is the package name, and we're like unstringifying it and reifying it as some sort of type in general is the sort of thing we're doing. And we can construct a library name by calling lib. Okay, so lib is the function that we see here. So lib is going to take a package name and return a package. And it's going to do that by lib of name is going to return a library name, and it's going to append as it's going to like string append the name you passed into it after the library's directory. And I don't know what this is, but I'm guessing this is like putting in a literal slash. So it's going to be libraries / whatever you passed in as the name. This is really delegating to the library function. And let's see if we can find the library function. No? Let's see if we can find all occurrences of library. It's presumably in another file. All right. Cool. All right, let's look at rules. I think, if I remember correctly, these things, when you declare a module, these things are maybe the exports of the module. So I think we're exporting build rules, Oracle rules, package targets, top level targets, and tool targets. And we're importing a bunch of stuff. So top level target is of type rules. This rule calls need on all top level build targets that Hadrian builds by default, respecting the final stage flag. All right. So I'm not sure what need does, but I'm going to guess, since this is the top level rule, it's got to somehow figure out the dependencies of all of its. So if we're at the root, that root has some dependencies, like direct dependencies, and somehow the root, I think, needs to figure out all of its transitive dependencies. And so maybe that's what need is. So need, I'm going to guess, is going to return a list of things that a package needs. So we're going to set the verbosity. And then for each stage, we're going to call for m, which is like I think like a monadic mapping function. I'm not sure what the monad, maybe rules is the monad. I'm not sure whether there's an explicit monad or not. And we're in do. I guess this looks like IO round parentheses, and maybe rules is the monad. Is there a way of finding that out? That's what I'll guess. If okay, so we'll do some verbosity checking. Map M some stuff to get library names. Map M some more stuff to get program names, and it's taking the stage argument because we saw in the README that the stages are placed in different directories. So these are going to give you different directory names, presumably based on the stage. And then let stage header. This is maybe just a string to show you the progress. And it's going to say building some stage and colon some whatever PS is, presumably the various libraries. Yeah, libraries and programs. And okay. So build stages, we're going to build up this. I think this is like a set builder notation. So all S such that S is an element of all stages, I think is how I'm supposed to read this. And S is, I don't know what the, maybe this is a literal less than sign. So maybe S is not in the final stage. And then targets, we're going to build up the list of targets by concatenating 4M. So some sort of monadic concat operation that maps over a list or some other structure. And we're going to get the stage packages and get mapm path stage package. Okay. We have some sort of wrapper stuff, and there's an explanation of why we need those wrappers in some issue. And then some more stage and package name massaging stuff. So package targets, but where's need called? Didn't it say it was going to call need? Yeah, okay. So it eventually called need on targets plus wrappers, where I think this double plus is a like list concatenation. So the ultimate thing it's going to do is it's going to call need on everything. And then need is actually the thing that's returned, right? So that's, I guess need is going to return type the type rules. Maybe. I wonder if need is defined here. I don't think it's defined here. Okay. And then we've got package rules, which package targets, package rules. So we have a sense of what a package target is. A package rules is of type rules, and also a function. It's going to return, I guess, whatever rules empty parentheses is. And we're going to do some stuff. We cannot register multiple GHC packages in parallel. Also, we cannot run GHC when the package database is being mutated by GHC package. This is a classic concurrent read exclusive write conflict crew. I don't think I've seen that abbreviation before. We're going to set max concurrent readers to 1,000. That seems like a lot. Do some package DB stuff. We're going to read and write some stuff. Then we've got some rules here. So we compile dependencies documentation program register. So rules register, presumably we'll register some rules into some data structure. Program, I'm not sure. So build program rules, and it's going to be called on read package DB. I don't know what a program rule is. I guess, was that the thing that was like building the binary or the executable? And we've got documentation, and dependencies will presumably somehow figure out the dependencies, and compile will presumably actually compile stuff. Okay. We can generate, this is going to generate package code. And the last thing that's called is rules, simple targets, completion rule. Okay. And then build rules. We've got some more of these rules things. I guess we'll have to take a look at whatever these things are. Generate, GMP, libffi, and then Oracle rules. And I think there's an oracles directory, so let's look at oracles in a bit. And here's target.hs. Presumably this is the library for build targets. And let's just double check Haskell module syntax. Here's a module, his name is tree, great. The module explicitly exports tree, leaf, branch, and fringe. Tree, leaf, branch, and fringe. Okay. So we're going to export target context builder, inputs, outputs, track argument, and module builder. Is that maybe like a submodule? And there's not much here. We've got some car stuff, some list stuff, Hadrian target, and builder and context. Track arguments. Some arguments do not affect build results and therefore do not need to be tracked by the build system. A notable example is -J uppercase N that controls makes parallelism. Given a target and an argument, this function should return true only if the argument needs to be tracked. Okay, so we're going to check whether something needs to be tracked, and that's all we've got here, other than the module declaration. All right. And fun times. Did we look at, let's look at way. Look at flavor and expressions. And then we'll start poking around in the directories. Okay, here's way. And so here's some actually interesting compiler stuff, I guess. So whether we want to build in vanilla, I don't know what vanilla is, but I guess it's some GHC kind of configuration. Whether we want to build with profiling, whether we want dynamic linking, build with profiling and dynamic linking. I'm not sure why that's not just the and of these two things. RTS only ways below. I'm not sure. I forget what RTS is. I think I looked it up before. So threaded, build multi-threaded, build RTS with debug information. Various combinations of RTS only ways, threaded debug, threaded profiling, threaded profiling dynamic. Let's look up RTS again. Runtime system, yeah. All right. So that's runtime system stuff. And we can, I guess, kind of manipulate ways. We have a list of all the ways. We can get a way prefix and a way suffix and whatever this stuff is. OSUF, HISUF, OBOOTSUF. All right. So that's ways. Flavors. These are the different, like, I guess, like configuration bundles. Flavor transformers. So these are transformers, and they can essentially add and delete command line options. So like we can use LLVM, we can use thread sanitizer, omit pragmas, fully static, etc. We can parse this flavor parsing. We can add arguments to the args of a flavor. And then W error. Turn on W error for packages built with a stage 1 compiler. Okay, so this is just, I guess, like an implementation of a flavor. And how's it going to work? It's going to call add args and build a GHC and do some stuff. And the arg is W error. And if we're cross compiling, I guess we'll do one thing. And if we're not, we're going to concatenate warn unused imports and warn unused top binds with mconcat. And then that's going to, I guess, produce a list. At first, I was confused about why we're not. I thought maybe we were just building up a string, in which case we would probably want like a space between the arguments. But I guess we're building up some sort of list, and that's going to be like interpolated into a string later. And so enable debugging, enable Haddock, those sorts of things. Okay, that's flavors. And then we've got expressions, which we saw a little bit of the documentation for. So we can get values from a configured cabal stage. Get context data. It's going to return an expra of A. We can get the stage. Is the build currently in the provided stage? Is a particular package being built? I guess at the current time? Or like, is it, I don't know if this means like right now, or is it scheduled to be built? Then we've got builder predicate A. This type class allows the user to construct both precise builder predicates, as well as predicates covering a set of similar builders. Okay, so we can construct build predicates. More predicate stuff. For example, this one says, whether or not bootstrapping compiler provides a threaded RTS. We need to know this when building stage 1, since stage 1 links against the compiler's RTS ways. All right, so threaded bootstrapper is a of type predicate, and it's set to be expression of flag bootstrap threaded RTS. All right. Library package is another predicate. It is equal to is library somehow applied on git package. All right. Let's see, what is the type of predicate again? It might just be a bool, but I think it's maybe a bool with some extra stuff. Okay, that's right. Cool. Okay, so let's peek around in these folders. Oh, wait, no, we didn't look at oracles, did we? Does oracles have its own file? It's just this folder. So let's see what's up with oracles. And then I was curious about what's going on with the rules. And let's stay there just to keep it a little bit bounded right now. So oracles has flags, flavors, module files, settings, and test settings. So maybe the oracle is kind of like a service that returns information. Let's take a look at a few of these. So the oracle's flag module is going to export things like get flag, platform supports shared libs, use libffi for adjusters. So these are like queries, I think. What about flavor? Ask dying GHC programs, ask GHC profiled. All right, what about module files? Decode module, encode module, find generator, HS sources, HS objects, determine builder. Yeah, I'm guessing that this is supposed to be like an oracle that you can query to find out information in like at the runtime to find information about the build. Let's look at encode module. Given the directory and file name, find the corresponding module name. For example, encode module data functor identity HS is equal to data.functor.identity. Okay, so this is just like string manipulation. What about HS objects? It's going to take a context and it's going to return action of file path. Find all Haskell object files for a given context. Note this is a much simpler function compared to HS sources because all object files live in the build directory regardless of whether they are generated or not. Okay, so, and it's just going to call interpret in context with context as an argument. And then it's going to call get context data on pd.modules. And then it's going to map m this function, I guess. This is a function that's built up out of module source, the composition operator, and object path context. And you're going to call it on modules. All right, this seems like relatively straightforward. I'm going to interpret oracles as a thing that you can query at runtime. You know, as you're coding up the build system, you may want to know whether something is true, and then you can use oracles to get that information. So here's rules. Let's see if there's a basic class that looks more fundamental than the others. Well, program is going to be important. Lint is important. Library, clean, cabal reinstall, and binary dist. There doesn't seem to be a single entry point, I guess. So let's look at for something that that we might expect to be relatively simple. How about dependencies? And it's so rules.dependencies will export build package dependencies. All right. And so let's find build package dependencies first. Okay. It's a relatively small file. So here's build package dependencies. It's going to take, forget what the, it's going to take a list. This is just a list. And inside the list are tuples. And each tuple it's a tuple of resource int. You're going to take a resource and an int, or a bunch of them. And then you're going to return a rules. And we're going to get build root rules. We're going to call build root rules and get the root. And root, this seems to be, I think that, so this is a string. This is an operator that I think we've seen in the context of strings before. I don't know what this percent right arrow is, but maybe it's like piping in this string as an argument to a lambda, and the lambda is going to take the variable mk. I think I'm not positive. Again, I don't know Haskell, so if you're watching this and you do know Haskell, I'm not sure this is what's going on, but I think that's taking the string, piping it into a lambda that takes mk, and the lambda is going to do some stuff, and it's going to call dep make file with some stage information. Or no, it's going to call get dep make file root mk, I guess, and assign that to dep make file stage package path. And then we're going to call unsafe find package by path. And all right, on the package path, and we've got some context stuff. And extra is going to be maybe return stage lookup package. So we're looking at more package stuff. We're going to look up sources, whether the context has sources, I think, or we're going to get the sources. Interpreting context generated dependencies. So we're going to take the generated dependencies and interpret, and whatever it means to interpret them in context. Maybe like the context might have things like, the context seems to have stages, stage information, the package name, maybe whether the build is vanilla, and whatever in place is. So depending on things like the stage and the package, we're going to get the dependencies. We're going to call need on it. We're going to call need on the list that's the concatenation of sources and generated dependencies. We've got this if, depending on whether the source is null. And if it is null, then we're going to write file changed mk with the empty string. Otherwise, we're going to build with resources rs on the target context, GHC find HS dependencies, some context of sources, and whatever mk is. And then we're going to call lift.io, apply it to map. We're going to map append file mk format extra, and remove file mk back. So I guess this is probably just taking whatever, making a backup of whatever was there before, maybe. Yeah. Okay. And then the root is going to, and then, okay, so that's, I guess, stage one. This seems like it's maybe making, I don't know what mk is. Is that a GNU make file? Not file format, file extension. Yeah, I think maybe it's a make file. All right. So I think that what this is doing is maybe configuring some sort of make file. Maybe. So we've got dependencies.make. Or maybe we're generating dependencies.make. And here it's dependencies but not .make. And for all of these, I guess we're going to put this string in, and we've got a lambda, and for the deps, we're going to do make deps read file dep. So we're going to read the, I guess, make file that perhaps that we just created, and write file change is going to write and maybe somehow signal that something changed. And for each of and we're going to pass in deps as a parameter. Unlines is kind of just like a string manipulation thing, and similar with unwords, I think. And we're doing a bunch of mapping because we've got, I guess, multiple deps. And we're going to call by map, unified path, map, unified path. I think that's more path stuff. Some more stringy looking stuff. I don't know what group all with first FST is, but perhaps we're building up some sort of nested list and we're regrouping it. And then ultimately we're going to call parse makefile and make debs. Parse makefile on make debs. Okay. All right. So I think this is doing some real work. So where do we use RS? RS is like the resources that we pass in, right? This should be the list of resource int pairs. So where do we use it? Okay, we call it with build with resources. All right. So I think that this is basically a doesn't really return anything. I think it just changes files, maybe in the build directory. Parse makefile. Write file changed. Yeah. So I think it's just writing files. So this is basically maybe a version of IO, but for the context of rules. Just a guess. All right. Is this what we had here? Parse makefile. We've got parse dep makefile and get dep makefile. So where's parse makefile defined? Okay. Let's look in rules again. So we've got dependencies. I think that's what we just looked at. Binary dist cabal reinstall. Clean compile. I guess let's look at compile. libffi, nofib, program, register, RTS, self-test, simple target, source, dist, and toolargs. Let's look at compile just quickly. So compile package is going to take, again, pairs of resource ints, and it's going to return rules, empty rules, I guess. Rules for building objects and Haskell interface files. Maybe we can look up, let's see, Hadrian GHC rules. I mean, maybe the docs will tell us something interesting. I can read the wiki. Oh, maybe the rules are shake rules. Is that what's going on? Let's look at shake again. We do have a rule. Shake defines some build rules and calls development.shake. Yeah. All right. Let's look at rule. Module is used for defining new types of rules for the shake build system. For example, to support values stored in a database. Most people find that the default rules are sufficient. Shake built-in rules are ones map keys to values, e.g. files to file contents. For each built-in rule, you need to think, what is the key type, which uniquely identifies each location, for example, file name? What's the value type? The value is not necessarily a full value, but is the result people can get if they ask for the value associated with the key. For example, for files, when you need a file, you don't get any value back from the file, so a simple rule could have empty as its value, and what information needs to be stored between runs. This should be sufficient to check if the value has changed since last time. Okay, and we've got monad rules. This is maybe what you're looking at. Hey, what do you mean? Is this the source? Is that what I clicked on? Okay, here's the source for monad rules. So new type rules of A. Define a set of rules. Rules can be created with calls to functions such as development.shake dot parenthesis percent right arrow or action. Rules are combined with either the monoid instance or more commonly the monad instance and do notation to define your own custom type rules to blah blah blah. So rules, new type rules of A is going to be rules of reader T, shake options IORef, S rules list builder IOA, and it's going to derive a bunch of stuff. Cool. So the rule stuff, I guess, is shake stuff. And the reason we keep seeing rules with empty parentheses is because A, I guess, is the empty type or something. I'm not sure how to think about that. But that ultimately, I guess, resolves kind of to an IO of A, which corresponds to like a bare side effect action. So I think that these are all, they're essentially not returning anything. They're just being called with their side effects. And so that means, I think that not positive, but I think that ultimately what Hadrian is doing is it's a way of trying to script the generation of GNU make files. Like it sits on top, it sits ultimately maybe on top of GNU make. And the job of Hadrian is to know about Haskell and to use its knowledge of Haskell to generate the appropriate make files. And then the compile steps, it's essentially just going to call out to the existing GHC, which perhaps knows about make files. I'm not sure. But that's going to be my mental model for now, at least. All right. So, is there anything else we should look at? Flavors, I think I understand enough of. You configure things, and there's kind of like an interface to change the configurations. Expressions, I don't feel like I understand, but I'm not sure how important it is to understand. But let's take a quick look at expression, and then I think that'll be it. So expression is small. It's got type.hs. An expression is a computation that produces a value of type action A and can read parameters of the current build target. So it can read parameters, it can peek inside the build target, and it can produce an action. So this is like if we have some sort of DAG, this is the sort of thing that could visit every node of the DAG, look at it, and then decide what should be acted upon. And I think probably since it's returning a type action, I'm guessing there's going to be something else that somehow schedules those actions and optimizes them rather than having the expression be something. The expression is not something that acts. It's something that writes down the next action step, and then it's something else's job to act on them in an efficient way. So the following expressions are used throughout the build system for specifying conditions, predicates, lists of arguments, args, and ways, and packages. So type predicate h.predicate context builder, type args h.args context builder, and type way is expression of set way. Okay. And we're going to import qualified Hadrian expression as h. All right, this is expression.type. What is Hadrian.expression? Not sure. So is there anything else outside of source? There's Bootstrap and there's docs. What's Bootstrap got? Bootstrap is Python stuff and some JSON. Bootstrapping Hadrian. So these are like scripts, I guess, to Bootstrap. Config, I'm going to guess, is not so important. Okay. I'm curious now, like, what's actually going to do the actions? Maybe, let's see, stage, compile, not compile. Is it the builder? Did we look at builder? I don't think we did. We're going to export a bunch of stuff, R mode, CC mode, configuration, dependency stuff, and import some shake stuff. Like, okay, here we go. Shake command and shake classes. I'm guessing command will be important. All right. So GHC can be used in 4 different modes: compile a Haskell source, compile a C source, extract source dependencies, and link object files and static libraries into an executable. So this is just an enum of things that GHC can do. To configure a package, we need 2 pieces of information, which we choose to record separately for convenience: command line arguments to be passed to the setup script, and package configuration flags that enable or disable certain package features. Okay, so we keep them in a data structure. And then we've got package mode that has like things like recache, dependencies, copy. Okay, lots of definitions. This is looking promising. A builder is a usually external command invoked in a separate process via command. Here are some examples. So we saw some examples of these. And so here's the list of builders, including Alex. For whatever reason, Alex is the first example they give in both here and in the README documentation. But we've also got other things that I recognize, like Haddock, make, which I'm going to guess is GNU make. Happy, I think I've seen before, but I forget what it is. You can derive constants. I don't think that's like an external function. Some Cabal stuff. Opt dump, and nm, I think are standard Unix tools for working with binaries. Make info might also be a standard Unix tool, but we also have Python. Sphinx is a documentation generator, I think. Tar for making and working with tarballs. XE LaTeX for maybe LaTeX documentation created in LaTeX. And whatever unlit is in make index, which is from XE LaTeX. I'm not, maybe there's a fancy way to pronounce that, but I don't know. And then Git. And then binary, hashable, and data are all of types builder. They're variables of types builder. And I guess the idea is that you can assign binary to different builders. Here's builder provenance. Some builders are built by this very build system, in which case builder provenance returns the corresponding build context. Okay, so things built by this, so things that return contexts. Okay, this comment tells us that if it's built by this build system, it returns a context. It doesn't say whether that's an if and only if. So there might be some things that return context that are not built by this build system, but I think the natural way to interpret this comment is that everything here is built by this build system, and that includes derived context, gen apply, which is presumably you're going to apply some function related to gen, maybe generating code or something. GHC, Haddock, Haskell to HSC to HS, which I think is maybe like a C thing, maybe like converting C code to Haskell, or applying the preprocessor. Haskell preprocessing for CFFI bindings. The HSC to HS command can be used to automate some parts of the process of writing Haskell bindings to C code. It reads an almost Haskell source with embedded special constructs and outputs a real Haskell file with these constructs processed based on information taken from some C headers. Okay, so this is like a code generation tool to make it easier to write Haskell bindings to some C library if you have the header for it. All right. H.builder is a builder with a bunch of stuff. It's got action file paths, runtime dependencies. We can query the builder for some information. Contrast this with runtime builder contrast this with run builder with, which returns action, empty parentheses, maybe empty type, however you pronounce that. This returns the standard out from running the builder. So it's going to return action string. And it's got these messages, I guess. That's the thing. Okay. What's this? Run builder with. It's going to return action of empty. So assuming that action works similar to rules, I'm going to guess that this is essentially what in C would be a void function, a function that's executed for its side effects for whatever it does with the environment, maybe writing files or compiling files. And rpack, runpack, maybe this is R, the Unix utility, the archive utility for making like library stuff. Auto reconf, configure, gen apply. Actually, yeah, we have command. Okay, yeah, let's look at this. So rpack of stage, we're going to get some temp file. If used template, then run R. But I don't know what run R is. But I saw something with commands. Yeah, okay. So command env c change, I guess, directory to this directory. And sh, presumably the shell. I forget what it's just sh is. Maybe the Bourne shell? And a path and build options and build args. Inject bin bash into, okay, so I guess it's assumed to be bash. Inject bin bash into libtool instead of bin sh, otherwise Windows breaks. To do, figure out why. So okay, so env is going to be add env config shell bash. All right. Yeah, so this is like configuring, this is like somehow mapping what maybe like a name or a command to the thing that I think actually executes external commands, like xelatex. Xelatex produces an incredible amount of output, almost all of which is is useless. Suppress it unless user requests allowed build. And where are we actually calling it? So we have this command, some output stuff, path, build args, and then some stuff about whether LaTeX failed. But where do we actually decide that xelatex is being called? Maybe that's part of build args or path? Path equal builder, path, builder. So run builder with. You're going to take a builder and build info. Yeah, I'm not sure. So somehow it knows to run xelatex, and that's encoded, I think, in the somehow in the fact that this is called xelatex, or maybe here we go, system builder path. Here we go. Xelatex from key xelatex, and then from key is, I guess, going to look in some database where it found xelatex, or maybe it's going to call package config or something. Let's see if we can find from key. Where from key of key is equal to do, let unpack equal from maybe error cannot find path to builder. So the error condition, did you skip configure? Otherwise, if we didn't skip configure, the path is going to be unpack something lookup value and config file key. So we have to call configure first, and configure, I guess, is going to find all of our stuff. Okay, so this builder seems to be where the action is at, and as we sort of put together as we were reading the code, builder is really just shelling out to other utilities, and the point of Hadrian is mainly to set up, I guess, the working directory so that it's the way that GHC expects. And like the API of Hadrian is there to allow you to specify and configure the make system, where make is a little bit brittle if you're just trying to do it by hand and you want to commit something to the repository source tree. So that was pretty interesting, at least for me as a non-Haskell person. It's a relatively simple build system, much simpler than something like Bazel. So you get to kind of you get to cover more area by looking at less code. So that's always fun. And that's it for me. Thanks for watching.